Hey everyone, welcome back to my channel. Today I'm super excited to bring you a brand new video, Learn Python with 10 exercises. Whether you're just starting out or looking to sharpen your skills, this video has got you covered. We're going to take you through 10 exercises, ranging from beginner to advanced levels, to help you master Python step by step. So, grab your favorite drink, get comfortable, and let's dive into the world of Python programming. Requirements to run Python on your computer or laptop. Python interpreter. You need to install the Python interpreter on your computer. You can download the installer from the official Python website, www.python.org/downloads, and follow the installation instructions appropriate for your operating system. You can also watch my video about how to install Python on your computer. I have given the link in the description. Operating system. Python is available for various operating systems including Windows, macOS, and Linux. Ensure that your computer's operating system is compatible with the version of Python you are installing. For Windows, you need minimum of Windows 10 to install Python on your computer. Text editor or integrated development environment, IDE. While not strictly necessary, having a text editor or an IDE specifically designed for coding in Python can greatly enhance your programming experience. Some popular choices include Visual Studio Code, Pycharm, Sublime Text, and Atom. Also, you can learn Python coding by going to Programmize online Python compiler to achieve the same task. You can find the link in the description. In the first example code, we will prompt the user to input 5 values, stores them in a list, finds the largest value from that list and then prints the result. Let's look at the code. This line initializes an empty list called values. This list will be used to store the 5 values inputted by the user. This line starts a loop that iterates 5 times. The loop variable I takes on values from 0 to 4. Inside the loop, this line prompts the user to input a value. Input is used to receive user input, and float is used to convert the input into a floating point number, a decimal number. The prompt message includes the iteration number I+1, so the user knows which value to input. This line appends the inputted value to the values list. In each iteration of the loop, the inputted value is added to the list. After the loop finishes, this line uses the max function to find the largest value among the elements in the values list. The max function returns the maximum value from the list. Finally, this line prints the result. It displays a message indicating the largest value found using the max function. Let's run this program and find the highest value amongst the 5 values. In this example, we have created a basic calculator program that can perform addition, subtraction, multiplication, and division. It asks the user to input 2 numbers and an operand. Then performs the specified arithmetic operation using the input numbers and operand. Let's dive into the code. For functions, add, subtract, multiply, and divide are defined to perform basic arithmetic operations. Add function will takes 2 numbers x and y as input and returns their sum. Subtract function will takes 2 numbers x and y as input and returns their difference. Multiply function will takes 2 numbers x and y as input and returns their product. Divide function will takes 2 numbers x, dividend, and y, divisor as input and returns their quotient. It also checks if the divisor is 0 to avoid division by zero error. The program prompts the user to enter two numbers, number 1 and number 2, and an operand to specify the arithmetic operation to be performed. Based on the operand entered by the user, the program determines which arithmetic operation to perform using a series of if statements. If the user selects the plus operand, then add function will be called and the values of number 1 and number 2 will be passed to x and y, and add function will return the sum of x and y. Similarly, if the user selects the subtract operand, then subtract function will be called and the values of number 1 and number 2 will be passed to x and y, and subtract function will return the result after subtracting the value of y from x. If the user selects the multiply operand, then multiply function will be called and multiply function will return the result after multiplying the value of x and y. If the user selects the divide operand, then divide function will be called and function will return the result after dividing the value of x with y. If the user entered an invalid operand, then the program will return the error message invalid operand. Finally, the result of the calculation is printed to the console. Let's run this program and perform some calculations. Let's try by entering a wrong operand. This program allows users to select a pizza from a menu, choose its size and toppings, specify the number of pizzas, and provides an order summary with the total price. It's a simple example of how you can implement a basic pizza ordering system in Python. Let's dive into the code and learn how this program is working. Display menu function. This function takes pizza menu as input and displays the available pizza options to the user. It iterates through the pizza menu list and prints out each pizza's name and price. Enumerate is a built-in Python function that allows you to loop over an iterable, such as a list or tuple, while also keeping track of the index of the current item. It takes two parameters, the iterable you want to loop over and an optional start index. By default, it starts from 0. Order pizza function. This function handles the pizza ordering process. It prompts the user to select a pizza by entering the corresponding number from the menu. Then it asks for the size of the pizza, small, medium, or large, and validates the input. The program performs basic input validation to ensure that the user enters valid options for pizza size, and selects a pizza from the menu. Next, it asks for toppings. The user can enter multiple toppings separated by commas, and it splits them into a list. After that, it asks for the number of pizzas the user wants to order. Finally, it calculates the total price based on the selected pizza's price and the number of pizzas ordered and prints out an order summary. In the order summary, the program will return the pizza name selected by the user with price, pizza size, topping, number of pizzas ordered by the customer, and finally the amount of the total order. Main function. This function initializes the pizza menu list of dictionaries containing pizza names and prices. It calls the display menu function to show the available options to the user. Then, it calls the order pizza function to take the user's order. Let's run this program and order a pizza. I am going to order the pepperoni medium pizza with olives topping. I want 2 pizzas. And here is my order detail with total amount. Let's try by adding a wrong pizza size. See, the program will not continue until you enter a correct pizza size. You can add multiple checks in your program to ensure that user is entering correct data. This program presents a list of 10 grocery items with their prices to the user. It then asks the user to select an item and specify the quantity. The user can continue adding items to their shopping cart or choose to finish shopping. At the end, the program will show the list of the items with quantity and price, and total of all the items at the end. Let's dive into the code to see how this program works. This is the main function where the program execution starts. We define a list named grocery items containing dictionaries, each representing a grocery item with its name and price. An empty list named cart is initialized to store the items selected by the user. There's an infinite loop, while true, to interact with the user and manage the shopping process. Inside this loop, we display the available grocery items using the show grocery items function. The user is prompted to select a grocery item and specify the quantity. The selected item is retrieved from the grocery items list and added to the shopping cart. The user is asked if they want to add another item. If they choose not to, the loop breaks. After the user finishes adding items, we display the items in the shopping cart along with their quantities and individual prices. The total amount for all the items in the cart is calculated using the calculate total function and printed to the user. Show grocery items function. The function takes one parameter, items, which is a list of dictionaries. Each dictionary represents a grocery item with its name and price. We print a header indicating that we are displaying the available grocery items. We iterate over each item in the items list using a loop. The enumerate function is used to generate a sequence of tuples containing the index and item from the list. We start the index from 1 to make it more user-friendly. Inside the loop, we print each item's number, name, and price formatted nicely using f-strings. The price is formatted to display 2 decimal places. By calling this function, we can easily display the list of available grocery items to the user with their corresponding prices in a clear and organized manner. Calculate total function. The function takes one parameter, cart, which is a list of dictionaries representing the items in the shopping cart. Each dictionary contains keys for name, price, and quantity. We initialize a variable named total to store the total amount for all the items in the shopping cart. This variable is initially set to 0. We iterate over each item in the shopping cart using a loop. Inside the loop, for each item, we calculate the subtotal by multiplying the price of the item by the quantity, and then add this subtotal to the total variable. After iterating over all the items, we return the total amount, which represents the total cost of all the items in the shopping cart. This function efficiently calculates the total amount for all the items in the shopping cart by iterating over each item and summing up their subtotals. Let's run this program and try to add 2 or 3 items in the shopping cart. Let's add bananas with quantity of 5. Now it's asking if you want to add another item in the list. We type yes. Second item we are going to add is chicken with quantity of 2. And third item we are going to add is rice with quantity of 5. Our shopping is completed, so I will type no. Here is our shopping summary, all 3 items with quantity, price and total. And grand total at the end of the list. So viewers, we've crafted a simple yet effective grocery purchase program. By analyzing this program, you'll gain a solid understanding of utilizing dictionaries, functions, and loops to create a comprehensive application. Stay tuned for our next exciting project. This code defines a class named Cars with attributes for name, color, gears, and transmission. The Cars class is a blueprint for creating car objects. It has 4 attributes initialized with default values. Name, initially an empty string. Color, initially an empty string. Gears, initially set to 0. Transmission, initially an empty string. Object instantiation. 2 car objects, car 1 and car 2, are created from the Cars class. Setting object attributes. Car 1 is set to represent a Toyota car with white color, 5 gears, and automatic transmission. Car 2 is set to represent a Honda car with red color, 4 gears, and manual transmission. Output. 2 formatted print statements display the information about car 1 and car 2. The first print statement describes car 1, indicating that it is a white Toyota with 5 gears and automatic transmission. The second print statement describes car 2, indicating that it is a red Honda with 4 gears and manual transmission. Overall, this code creates 2 car objects with different attributes and prints a description of each. It demonstrates basic class definition, object instantiation, attribute assignment, and formatted output in Python. This code snippet defines a class called addition that encapsulates the logic for adding 2 numbers and then displays the results. It demonstrates several key concepts in Python: class definition, parameterized constructors, instance attributes, instance methods, object instantiation, and interaction with class instances. Here's a detailed breakdown of the code. Class definition. Addition class. The addition class has 3 class-level attributes initialized with default values. First is set to 0. It represents the first number for addition. Second is also set to 0. It represents the second number for addition. Answer is initialized to 0. This will store the sum of first and second. The constructor initializes the instance with given values for first and second. The parameters f and s are passed to the constructor during object creation, setting self.first and self.second to these values. Display method. This method outputs the values of first, second, and answer in a formatted manner, using the print function. It provides information on the numbers involved in the addition and the calculated result. Calculate method. This method performs the addition of first and second, storing the result in the answer attribute. Object instantiation and operations. Creating objects, obj1 and obj2. Obj1 equals addition, 1000, 2000. This creates an instance of addition with first equals 1000 and second equals 2000. It calls the parameterized constructor, initializing these attributes. Obj2 equals addition, 10, 20. Another instance of addition with first equals 10 and second equals 20. Calculations and results. obj1.calculate calls the calculate method on obj1. This sets obj1.answer to 1000 plus 2000 is equal to 3000. obj2.calculate calls the calculate method on obj2. This sets obj2.answer to 10 plus 20 is equal to 30. Display outputs. obj1.display displays the values of first, second, and answer for obj1, showing the addition result. First number equals 1000, second number equals 2000, addition of two numbers equals 3000. obj2.display, similarly, displays the results for obj2, with an output, first number equals 10, second number equals 20, addition of two numbers equals 30. Overall, this code demonstrates creating a class to perform a simple task, addition, constructing objects with specific parameters, calculating results, and displaying them. It reflects a basic structure for encapsulating and reusing logic in object-oriented programming. As our program grows bigger, it may contain many lines of code. Instead of putting everything in a single file, we can use modules to separate codes in separate files as per their functionality. This makes our code organized and easier to maintain. Module is a file that contains code to perform a specific task. A module may contain variables, functions, or classes. Let's see an example. Let's create a new file with the name of calculation.p. In the calculation file, we have defined a function add inside the calculation.py file. The function takes in two numbers and returns their sum. We can use the import keyword to import any module in another file. We have created a file with the name of calculation.py, so we can import our module by using import command like this. Import calculation. Now after importing the module, we can use all the functions defined in the calculation.py file. We have created add function earlier, we can use this like this by using print statement. Print module name. Function name and arguments which will be passed to get the results. Let's call the add function again to calculate once more. Remember, if you used any other symbol instead of comma between the two values, it will return the error. So always use comma to spare it the values. Our module is working fine. We can directly add the specific function from module, and in this way we don't need to write the module name each time when we call the function, we just need to call the function directly. We can import a specific function by typing from module name import function name. In our case, our module name is calculation and our function name is add, so we can import our function directly like this. Now we don't need to add the method name in beginning of the function add, so I am going to remove this. Now our function is working fine. If you want to add all the functions defined inside the calculation module, you can use asterisk to import all the functions. So guys, this is how we can create a new module and used it in another file. In the next exercise, we are going to learn how can we perform all the math calculation like add, subtract, multiply and divide by using a module. Let's extend our module to add the more functions. In the previous exercise, we created a module named add. Now, we're extending this module by adding new functions. First, let's implement the subtract function. This function will take two arguments, a and b, and return the result of subtracting b from a. Next, let's define the multiply function, which takes two values and returns their product. Finally, let's implement the divide function to divide two values. To use these functions, we need to import them. We can either import specific functions or import all functions using the asterisk sign. Once imported, we can utilize these functions in our code. Let's start by adding two values using the add function. For example, 10 plus 20 equals 30. Next, let's use the subtract function. For instance, 50 minus 20 equals 30, indicating that our second function is working correctly. We can also customize the names of the imported functions. For instance, if we frequently use the subtract function, we can import it with a shorter name like sub. This makes it more convenient to use throughout our code. It's essential to note that these custom names are valid only within the file where the module is imported. If you intend to use these functions in other files within your project, you'll need to import the module using the import function. Moving on to the third function, let's use multiply. Multiplying 10 by 10 gives us 100. Lastly, let's employ the divide function. Dividing 50 by 10 results in 5. You can also customize the name of the divide function upon import. And it will function the same way as the original divide function. Let's enhance this code and add an if condition, so that we can perform all type of calculations by entering the values and an operand like plus, minus, divide or multiply. So I am going to add if conditions in my code. This code will accept two inputs from the user and then ask the user what he wants to do, and perform the calculation as per operand given by user. And if the user given a wrong operand, then it will return the error, invalid operand. Let's execute this code to perform calculations. We'll input two values and an operand to specify the operation. For instance, if we want to add the values, we'll use the plus operand. We've entered two values 10 and 20 and an operand to add them. The result is displayed correctly. Now, let's test the code with other operands. Let's subtract 30 from 50. And it's showing the correct result. Let's divide 100 with 20. And it returned the answer 5. Now, let's try an invalid operand. I am going to give underscore as operand. As anticipated, we received an error message indicating an invalid operand. Our code is functioning properly. In this video, we will cover different methods for getting date and time using the datetime module and time module in Python. Later in this video, we will learn how to create a digital clock using a Python module. Let's dive in. This code retrieves the current date and time using the now function from the datetime module in Python. Here, the datetime module is imported, which provides classes for working with dates and times in Python. The now function from the datetime module is called. This function returns a datetime object representing the current date and time. The now variable stores this datetime object. Finally, the print function is used to display the value of the now variable, which contains the current date and time. When you run this code, it will output the current date and time. Here is another example, in which we can retrieve the current date using the datetime module. This line imports the datetime module in Python. The datetime module provides classes for working with dates and times. Here, the today function from the datetime module is called. This function returns a datetime object representing the current local date. The current date variable stores this datetime object. Finally, the print function is used to display the value stored in the current date variable, which contains the current local date. This code snippet utilizes the date class from the datetime module in Python to work with dates. Let's break down the code. This line imports the date class specifically from the datetime module. The date class represents a date, year, month, day, in the Gregorian calendar. The today function is called on the date class to obtain a date object representing today's date. This object is assigned to the variable today. These lines print the year, month, and day of today's date, respectively. They access the attributes year, month, and day of the date object today and display their values. When you run this code, it will print the current year, month, and day of the system state. This code will display the calendar for the current month and year. Let's break down this code. Importing necessary modules. Datetime, this module supplies classes for manipulating dates and times. Calendar, this module allows you to output calendars and provides various functions related to the calendar. The today function from the datetime.date class is called to retrieve the current date. It returns a date object representing today's date, which includes attributes like year, month, and day. Here, the year and month attributes of the date object today are accessed and assigned to variables y and m respectively. These variables store the current year and month. The month function from the calendar module is used to generate a formatted text representation of the calendar for the specified year, y, and month, m. This function returns a string containing the calendar, which is then printed to the console using the print function. If you want to print the calendar of any other month, just change the value of month variable. For example, I want to display the June calendar, then I have to write the in numbers like this. This code creates a simple clock application using the tkinter library in Python. Let's go through it step by step. Importing necessary modules. Tkinter, it is the standard GUI toolkit for Python. Tkinter.ttk, it contains themed tkinter widgets that have a more modern appearance. Time, it provides various time-related functions, including strftime, which is used to format time. This creates a tkinter window with the title clock. This function retrieves the current time using strftime, which formats the time as hours, minutes, seconds, and AM/PM. It updates the text of the LBL label widget with the current time. LBL. After 1000 time schedules the time function to be called again after 1000 milliseconds, 1 second. Styling the label widget. This creates a label widget, LBL, with a specified font, background color, and foreground color. Placing the clock label. This places the label widget, LBL, at the center of the tkinter window. Calling the time function and running the tkinter event loop. Time is initially called to start updating the clock. Main loop starts the tkinter event loop, which waits for events, like button clicks or window resizing, and processes them. When you run this code, it will create a simple clock GUI displaying the current time with a purple background and white text. The time will update every second. So viewers, here is how we can create our own module, or we can use predefined Python modules to perform several tasks. This code creates a simple calculator using Python's tkinter library. Here's a breakdown of the code. Importing libraries. This line imports everything from the tkinter library, which is used to create graphical user interfaces, GUI, in Python. This line creates the main window of the calculator application. This sets the size of the window to 312 pixels wide and 324 pixels high. This line prevents the user from resizing the window. This sets the title of the window to calculator. This function is called whenever a button is clicked. It takes the button's text as input, represented by the item parameter. It retrieves the current expression from the global variable expression. It concatenates the button's text to the expression string. It updates the text displayed in the input field using the input_text set, expression, line. This function is called when the clear button is clicked. It simply sets the global variable expression to an empty string and clears the input field. This function is called when the equals button is clicked. It evaluates the expression stored in the expression variable using the eval function. The eval function treats the string as a Python expression and calculates the result. It updates the input field with the calculated result and clears the expression variable. This global variable is used to store the current expression entered by the user. This variable is an instance of the string var class from tkinter. It's used to store and display the text in the input field. The code creates two frames. This frame holds the input field where the user enters the expression. This frame holds all the calculator buttons. Buttons are created for numbers, 0 to 9, operators, plus, dash, asterisk, /, decimal point, clear, and equals symbol. Each button is linked to a function using the command attribute. When a button is clicked, the corresponding function is executed. Main loop. This line starts the main event loop of the tkinter application. It waits for user interactions like button clicks and updates the GUI accordingly. Let's run this code and try our calculator. Here is our calculator. Let's try it by performing some calculations. First, try adding two values. Perfect. Let's divide two values. Working fine. Let's multiply two values. Let's try subtract. Our calculator app is working fine. So guys, here is how we can create a simple calculator by using the tkinter module. Let's move to the next exercise.